Hi, my name is Carolyn Tran. I'm enrolled in Physics 114, and today we will be talking about the observations of momentum and kinetic energy through collisions of two objects. And so, to further proceed, collisions happen every day. It can be happening between two objects, such as these two humans upcoming here. You see that the person is hurt. What happened was these individuals collided with one another as they try to run for the ball. This must have been very painful for all the players, unfortunately, and we'll see further what happens next. And then another example is this guy's kicking a soccer ball over here. He's coming into contact with the ball. So right when he contacts, he's just showing us some of the techniques that's to happen. So here he kicks the ball, and there's that slight contact that the ball and his foot has with each other. And so that is the type of collision right there that we will further discuss on the different types of definitions. And so, going on with the types of definitions, first, to know what a collision is, it essentially is a short duration interaction between two objects. For instance, the ball and the person is kicking the ball. That's a collision right there, or simply two people crashing into one another. There's also different types of collisions, such as a perfectly elastic collision where there's no loss of kinetic energy in the collision, depending on the system that you're working on, which we can further talk about, as well as inelastic collision, where the kinetic energy that is changed to some form of energy through the collision when two objects collide, and then the energy transfers from object to another. With that being said, momentum is a huge part of this understanding, where it is measured as the product of its mass and velocity, and is especially important to understand in physics, especially through the energy transfers between two objects. And so the momentum is important, especially when observing collisions between two objects, because the two objects when the total momentum of the two objects before the collision is equal to the total momentum of the collision, that means that the energy is conserved because the momentum stays constant and doesn't change in value. And so, because energy is conserved, this is also known as the law of conservation momentum. This essentially will be further explored in this lab to help us understand what it means in changing of energies through the collision of two objects. So, understanding momentum is significantly important because we want, like, the purpose of this lab activity in particular is to have a visual understanding of what collisions are, through understanding the law of conservation momentum by observing the changes in total energies and how momentum affects the two objects. Depending on having different masses, initial velocities, initial momentum values, in order to observe any changes in the final velocities, final momentums, and total kinetic energies. And so in this lab, we will be using this program right here. It's a simulation to observe the two objects. Depending on what the system is, we can see that you can reset, you can play, and once you play, the two objects collide. They'll give the times, and you can change the elasticity, of course. In this video, make sure that there is more data selected at this bottom box with the x, y, velocity, and momentum values for x and y values. That's significant to indicate any changes in the energies themselves and the momentum itself. So by adjusting the mass values and the velocity values, it seems like we got the same total kinetic energies. By looking at the chart or the data table, they are essentially the same values, just in reverse order. They add up to the same total kinetic energies, especially in the first two, table 1 and table 2, despite the changes in mass. And so this is an important indicator about that there's no total change in the energy system, therefore the energy is conserved. And the first two tables essentially revealed the perfectly elastic conditions. However, once we started looking at the perfectly inelastic conditions, the total energies end up being the same. However, despite changing the mass, and therefore there was no, because of it being an enclosed system, that these values didn't really change much um, from the previous values, as it can be seen over here. And because we found that, so essentially in this lab, what we found is that in an elastic collision, there's no net loss in the kinetic energy. And so both momentum and kinetic energies are conserved in elastic collisions. When applying the conservation of momentum, the initial and final velocities are the same as energies are transferred from one object to another. Therefore, essentially, there's no change in momentum. Not only that, total kinetic energy is conserved and in close isolated system, as seen where the two balls collided were colliding with each other. Um, there are, not saying that this lab is completely perfect. There may be potential source of error that might have occurred. For instance, the browser may automatically set the position of balls that affect the changes in the velocity momentum values. Furthermore, having a low elasticity value may impact friction, which wasn't accounted for in this lab. Maybe next time, changing that elasticity to observe any further changes may be something that we can do. For future research, we can also, I personally would like to evaluate the differences between elastic and inelastic conditions by altering the initial and final velocity and momentum values to see whether there are changes in total momentum kinetic values. Um, and so these are some of the changes that were observed in this video. However, this was a very thoughtful and applicable lab that revealed the significance of isolated systems, the significance of collisions, and how that alters the total energies within a system, whether it's enclosed or not. And that's the most important, valuable lesson that was learned. Um, and so, thank you for listening on to this lab report.